A tool that can be used to teach programming in your classroom, similar to the other tools, including the Sphero or the Bee-Bot, is a drone. Now, a drone is a very engaging tool. Students are extremely engaged with flying and controlling drones, and we can use the drone to have students learn and practice and undertake block programming. So this is a simple drone. It's a Parrot drone. It's called a Mambo, and it's relatively cheap at about 170 Australian dollars. There have been some cheaper options, but they need to be able to be compatible with the iPad or Android device. So I'm going to show you how I'm going to program the drone using the iPad. You can see there in the background I've set the drone up so that I'm going to fly it from where it is. On the iPad I use a program called Tynker, T-Y-N-K-E-R, Tynker. And there are a whole lot of apps and tools in Tynker that can allow you to learn how to program using just the Tynker program, which is a whole lesson on its own. But we're also going to use Tynker to control the drone. So I'm going to skip that, and we're going to go to the projects. So there's a projects button down here, and the projects button brings up the option for a new project. And the new project, I'm going to start a blank template, and I'm going to add a connected device. Now you'll see here that there are a number of different drones that you can connect to. There are some robotics programs you can connect to. You can connect to some Spheros and Ollies and light globes. Here are other drones that are new. This is it's not a flying drone, it's a jumping drone. And there's another drone here which flies. You need a lot more space to fly because it flies more like a plane. We are going to connect to the Mambo. Now, once we've got the Mambo set up, I'm just going to delete that character because we don't need him. Once the Mambo is connected, or set up, sorry, it's not yet connected, we can press the little triangle brackets, and it brings us to the programming screen where we can program our drone. Now, I don't like the start here where it says when actor is touched. I'm going to take that and throw it in the bin. I'm going to go here and get the one that says on start. So that means when I press the start button down the bottom, then the commands start. The first block there says, I'll take them all away just to show you right from the start. First block there, the first thing we need to do for a drone is to have it take off. So I get the takeoff block and put it in place so it's locked. See the little stars that say that it's locked in place. I can then set the speed to 50% and move it forward for 1 second. I'm going to then ask it to turn right, and I want it to turn all the way around. So I want it to turn right by 180 degrees. So we talk about degrees again. And I want it to fly forwards again, because it's going to go back to where it started from for another 1 second. And then our last command needs to be land. If I press play, I'm just going to move out of the way so you can see the drone do exactly that. It should take off, it should move forward for 1 second, it should turn around and face back where it came from and move back, fly back for 1 second and hopefully land back on the little stool that I set it on. Okay, so pressing play. move forward for 1 second, turn around, move back for 1 second, and it fell off. This allows us to have discussions about physics and science around why that would happen. We talked about things like turbulence and air movement and changes in the room. And when we get a room that has 2 or 3 drones in it, and we can see that the drones interact, the air around them starts to interact and cause changes in the flight path. So this is a direct connection to the science curriculum at a number of year levels. I will often give students the iPad and the drone in pairs. I most often work in pairs or groups of 3 with all things, because collaboration is an important skill that students need to learn. And I'll get them to play, learn by play. So all the students love the flip option. The drone will flip forward, it will flip backwards, it will flip left, and it will flip right. And then land. So I'm going to show you now how we can program the drone to take off, and we're going to use a tool called a repeat. So this is like a loop. It will repeat what is inside that loop as many times as we tell it to. So I'm going to say 3 times, I want my drone to flip forward, and then I want it to move forward for 1 second. And it's going to repeat that 3 times. And then once it's repeated it 3 times, it will land. Okay, so let's see what that does when we press start. Flip forward, move forward 1 second. Flip forward, move forward 1 second. Flip forward, move forward 1 second, and land. Okay, so now we look at our program, and that's exactly what we've asked it to do. Now I would then ask students to meet a series of challenges. I'll get the students to start with the drone on the floor wherever they are in the room, and I'll set up a stool or a chair or a circle on the floor, and I'll issue the teams of 2 or 3 students to program their drone to fly from where they are to the circle and land in the circle or land on the chair. And this requires students to undertake a series of problem-solving activities and reasoning and resolve some issues. Now, some students will use programming 100% to solve the problem. So they'll start their drone wherever it takes off from, and they'll fly it to the chair or the circle. Some students will use physical location. So if the drone with the program that they set misses the chair by 15 centimetres, they will bring the drone back and have it start 15 centimetres to the right or to the left, whichever it missed by, so that it's got more of a chance to land on the chair. Both methods are valid. It depends what you are seeking to do in order to achieve an outcome. But if it's about problem solving, then changing the start position or the end position is a valid option. I tend not to let students move the chair. They've got to move their drone from the starting point. Once they've achieved that, and for some students they'll get it first time, for other students it will take multiple attempts, and they're the ones that are learning the most. Once they've achieved it, I issue them with a second challenge. I issue them with the challenge to now take an indirect route. So their previous challenge took off from point A, flew to point B. An indirect route would be that it would take off from point A, fly via point B to go to point C and land. Then issue them with challenges just to add difficulty, add a flip in, etc., etc. You can get them to fly over things, you can get them to fly under things, you can get them to fly around obstacles, etc. Another interesting challenge which students really find difficult or challenging is similar to the challenge with the Bee-Bots, is to get them to fly 2 drones and get them to dance. Now this challenge is far more complex because they can go over top of one another or under one another, or they can do it simultaneously, and they can dance and they can flip next to one another and they can dance in really interesting ways. Kids love this challenge.